In their simplest form, expressions can be used to simply tie similar properties from one layer to the other. For example, we see a little car on screen here. This is a three-dimensional Indy 500 car made with a few simple cards and some solid shapes. Very cute, fully 3D. And I've already pre-animated one of the wheels on our car here. If I tap the space bar, you'll see that the wheel layer at the bottom of the list in the timeline is already pre-animated, and it rotates at about 2 rotations per second through our 10-second comp. That's fine. Our back wheel, however, is not set to rotate, and while we could, as you've seen many times in the past, copy the keyframes for rotation from our first wheel to the second wheel, we're not going to actually do that. We're going to use an expression to tie these properties together instead. And a great advantage to doing this is it keeps us from having to adjust more than one layer once we get our expression relationships set up. So what do I mean by that? Well, let's first of all set an expression for this layer. We can select the Z rotation property. That's the property that we want to create an expression for. And with the property highlighted, we've got a couple of choices. One is we can go to the animation menu and choose Add Expression, if you like. There's also a keyboard shortcut for it that I don't really recommend that you learn. One reason I don't typically like the menu commands for expressions is that usually the biggest advantage to a menu command or a keyboard shortcut is it allows you to set expressions for multiple layers at the same time. But since you can't modify expressions on more than one property at a time, this has very little value in the real world of working with expressions. So instead of using this menu command or this keyboard shortcut, I'm going to show you a trick that I will use from now on in After Effects to add an expression. And that is, I'm going to hover over the stopwatch for the property, and I'm going to add the Option key on the Mac, the Alt key on Windows, and click. And when I click next to the stopwatch, we now see a little equal sign button that's activated. And underneath the name of our property, we now see the word expression, and it's telling us that it's modifying the Z rotation of our layer. In addition to that, the numbers for rotation have now turned red, meaning that they are controlled now by the expression, not by setting any subsequent keyframes. Okay? Expressions can work with keyframes, as we'll see, but in general, you don't want to go back too often and modify keyframes after you've set expressions. The whole point of expressions is you want them to handle the animation for you, not the keyframes. Let's look what's happened over to the right-hand side of the timeline. A field has opened up here with the word rotation automatically typed into it for us. And if you hover your mouse over the bottom edge of this field, you can actually expand it out and create a larger field. This is very important to do because very often when you're copying and pasting expressions, you won't see the whole expression until you expand out this field. We don't really need to do that right now because we'll be working with very, very simple expressions. And by default, it typed in an expression for us. That expression is simply the word rotation. And all that's telling us is right now, until we tell it otherwise, the rotation of this layer is controlled by the rotation of this layer. In other words, it's just controlling itself with its own values. It's an expression that does nothing, in other words. We obviously don't want an expression that does nothing. We want an expression that does something. We want an expression that ties the rotation of this layer to the rotation of another layer. And we do that by typing in an expression script. Now, expressions are based on JavaScript version 1.2. If you want to learn JavaScript, that's great. That's not what I'm going to be teaching you here, though. I'm basically going to be teaching you to work with basic expressions inside After Effects, and After Effects gives you a lot of tools that keep you from having to do too much typing in that field. And one of the main tools is this pick whip right here. We've already seen pick whips with regards to parenting and parents. In fact, I'm actually going to get rid of our parenting panel so that we can see our expression a little bit more clearly. Oops, when I did that, I deselected our rotation, and I want to make sure that that word is highlighted because this pick whip is actually going to type a little script for us. I'm going to click and drag on this pick whip, and I'm going to drag it to the property that's going to be providing us with the information we need to control this layer, and that property is the Z rotation that's already been animated on our wheel layer. And when I let this go, After Effects has automatically typed in this expression for us. It's telling us that within this comp, the layer named wheel, which is the bottom layer here, we're going to use its rotation, not our rotation, to control this parameter. In this comp, the layer wheel rotation is now going to control the rotation of this layer. All right? Now, one more important thing. You might be tempted now to tap the space bar to preview our animation, but if you do, we're only going to be adding a space at the end of our expression here because we're in a text field. So I'm going to delete that space. Before you can actually see the results of an expression, you need to either hit the Enter key or just click out of the expression somewhere to deactivate it. And now that we've done it, a quick tap on the space bar shows us that we now have both of our wheels spinning merrily, controlled by our first wheel. So no keyframes on this back wheel. All of its rotation information is coming from the rotation information of the front wheel. What's cool about this is now that we have this relationship set up, and as long as it took me to explain it, it's really not very complicated. We just basically clicked one button and then clicked and dragged a pick whip, and boom, we were done. Now we can actually duplicate the layer that we just set up and drag that duplicate back a little ways in 3D space. Let me change to our top view and line our wheel up here a little bit better. I'll duplicate the layer one more time. So now we've made two copies of our expression layer. Let me jump down to our front view now. And actually, let's jump back to home just to make sure that everything's lined up properly. And let's drag the copy that we just made to line it up with the frontmost wheel. Now if we jump back to our custom view one, we should see four nice little wheels attached to our car, all of them doing exactly the same thing at exactly the same speed, which is very cool. Now a keen eye might observe at this point that all four wheels are not only animating at exactly the same speed, but they share the exact same orientation while they're doing it. They're very clearly copies of each other. If you wanted to offset these wheels from each other just a little bit, the fact that they are 3D wheels gives us a couple of different ways to do that. Let's go down and look at our rotation properties for this last wheel, for example. And more specifically, let's look at our orientation, because our Z rotation is controlled by the expression, as we can clearly see. It's marked in red here, but we could also offset the Z value discrete from what the expression is producing by just adding or subtracting a little bit of rotation by cranking our orientation value. So a little adjustment of that gives us an additional 30 degrees offset, and now the two wheels will continue to spin at the same speed, but they'll be offset just a little bit. So that's one way of offsetting similar values in a situation like this. But another way is to actually modify the expression itself. We can see our wheel number 2 expression here, and a quick keyboard shortcut for revealing the expression on this layer, layer number 5, which on my screen says wheel 2 with an asterisk next to it, but on your screen it probably says wheel 3, because they fixed that problem with After Effects 6, is to select the layer and type the letter E twice, quickly. EE solos the expression for that layer. So now we can see the expressions for wheel number 2 and the expression for wheel number 3 over here. And now let's see how we could modify these expressions to also offset the values that are created by the expression. And in a situation like this, it's unbelievably simple. All you have to do is incorporate some very basic math, meaning plus and minus kind of math. So we already offset the value of one of our wheels by 30 degrees. Let's take another one of our wheels, maybe 60 degrees. So let's subtract 60 degrees from this expression by just typing in minus 60 and hitting enter. And similarly, let's go to the expression above it, and let's add 30 degrees to that one. So we got plus 30 and minus 60. And now if we look at the results, you'll see that we're getting 4 wheels that are all angled at kind of slightly different angles. Now, it turns out that I've managed to replicate the orientation here by adjusting the orientation with the plus 30 degrees that I just added to my expression. But obviously, you have 2 ways to fine-tune that and 2 ways that we could make that look a little bit better. So obviously, expressions are very, very easy for connecting one property to another. Another great place that this is useful is in the world of 3D. Let me jump back to frame 0. Let's add a light to our scene. Command Option Shift or Control Alt Shift on Windows, L for a light. We'll just keep the default settings, light 1, and call it a spotlight. That's fine. And Command Option Shift C for camera. And once again, we'll just accept the default camera settings and click OK. Now you'll see here in the window from our custom view 1, we now have a camera and a light icon. That's fine. But let's take advantage of expressions now to simplify one of the more complicated things about After Effects 3D, and that's controlling exactly where the camera and the lights look at or point at. If I twirl open my light and twirl open its properties, the first one we'll come to is point of interest. I'm going to expand my window a little bit here so we can really see what we're doing. And what I'm going to want to do is have my light's point of interest connect to the center of the car body. So let me select this layer and solo the position property for this layer, which will track the center of the car body or where the anchor point is. We're going to actually use the position of this layer to drive the point of interest of our light source. We'll set an expression by holding down the Option key on the Mac, Alt key on Windows, and clicking on the stopwatch. And then we'll pick whip down to the position of our car body and hit Enter. We haven't seen much difference on screen, but that's okay. We'll show you in just a second how well this worked. Let's do exactly the same thing to our camera layer. I'll twirl open its properties and set an expression for point of interest with the Option key or Alt on Windows, click, and pick whip the results down to the position of the car body again. And now both the camera and the light are pointing at the center point of our layer here. So no matter where we position the light in space or the camera in space, and let's change our view to a front view here to make sure that our camera is actually above and looking down at our little racer, and that our light source is up above and pointing down at our little racer. If we look now from our camera view, you'll see we're definitely pointing right at our little racer, and our light source is always pointing directly at our little racer. This isn't that big a deal because we could have very easily just sort of dragged the point of interest into this position, right? The important thing is now we're free to animate our car. We can move the car around on screen, and the camera and the light will continue to follow the car no matter where it goes. I don't need to worry about expressions anymore, so let me twirl those down. I do need to fairly quickly set up a parent relationship here, so let me choose my parenting panel to bring it back. And I'm going to select the fin, the flat part of the car body, and all four of the wheels, and make sure that they're all parented to the center car body. So that's done. And now I can adjust the position of our center car body in space. Just click and drag around. You'll see no matter where we position the car, the camera is always looking at it. It's almost as if we're rotating the camera around, but we're not. We're actually moving this car in X space, in Y space, even in Z space. And wherever we move it, the camera continues to point at it, and the light continues to point at it. So that's a very important use for expressions in 3D. Is you can use expressions to force a camera or a light source to always point at a layer, which is a very, very useful thing. So that's basically how to hook up an expression, which is a pretty simple thing to do, as long as the properties that you're hooking up are similar. A point of interest, for example, tracks position, and so does the position of a layer, so those values are the same. Rotation, copied to rotation, provides no confusion at all. But what happens when you want to connect items together that are not directly related, like rotation to position, for example? Well, cases like that can be pretty straightforward, but we also might need to do a little bit of finagling with the script. So let's open up the Properties and Dimensions composition. Now, this project is called Properties and Dimensions because many of the values that are responsible for setting positions or keyframes or whatever are multi-dimensional in After Effects. For example, rotation is considered to be one-dimensional because you only have one value to modify. Scale, on the other hand, is two-dimensional. Once again, I'm talking here in 2D space. If we were in 3D, these values would change and we would have 3 dimensions. But you can see here very clearly we have both the X and the Y dimension to deal with on scale and only a single rotation value to deal with. So how do we connect values from one of these to the other? Well, let's take a look at that. What if, for example, we want to control the scale of, for example, the green vertical bar here that we see in our meter? We want to control that with this lever on the left, with the dial that we see here. Now, I've already got things set up here fairly clearly so that the rotation point on our lever is properly set in the middle. If we rotate it around, the dial moves with it, which is kind of cool, but we want to have these values control the levels of the meter in there. Or in other words, we want to have it control the scale of the meter that we see here. So let me zoom in on this a little bit. I'm actually going to widen up our composition and pan down on it a little bit. So hopefully we can zoom in a little bit and see things more clearly. Now, in addition to setting up the anchor point for the rotation here, I've also taken it upon myself to adjust the anchor point of the green bar so that the scale is occurring from down at the bottom. So if you're setting this up from scratch, you need to make sure your anchor points are properly set up as well. So we've got our anchor point at the bottom here, and our anchor point on our lever over here is centered right at the rotation point. So let's take our green meter, which is the meter 1 element that we see right here, and we want to control its scale with the rotation of the handle. So the handle is going to be driving things. We want to set an expression on scale, and we want to pick whip the scale values back to rotation. So I'm going to hold down my Option key, Alt on Windows, and click on the stopwatch to enable an expression. And let me pick whip this value up to rotation. Now I don't need to see my parenting anymore, so let me hide this panel. And that'll widen up our expression field just a little bit. And once again, After Effects has automatically typed an expression for us. But this one looks a lot more complicated than the previous one. Well, it's not really all that complicated. Some of the big tips that you can see here that are going to help us figure out this expression are the fact that it's all in brackets. That tells us that we're looking at an array. We're looking at a multi-dimensional list of numbers. Anytime you see brackets like this with commas on the inside, typically the bracket is containing a list of numbers that are going to represent some multi-dimensional values. So in this case, we need the x value and the y value. So the x value is going to be determined by this comp's layer handle 1b rotation, and the y value is controlled by exactly the same identical thing. This comp's layer handle 1b rotation. That's basically what we just pick whipped to. The handle that we see there in the Windows rotation property is going to be controlling both the x and the y of our layer. And you can clearly see because our rotation value of our handle defaults to 0, our layer has now disappeared. Let's go turn our handle and see what the results are in our meter. We'll crank the handle here by using the drag properties down here. Well, we've managed to get the rotation of our handle to control the scale of our meter all right, but we've obviously got a problem. And that is, it is both controlling the x and the y of our meter. And that is not giving us a bar that simply moves vertical. It's giving us a bar that scales up altogether, which is not what we want. So we're going to need to modify After Effects default script a little bit. Remembering that this first phrase here before the comma controls the x scale of our layer, we basically just need to select this text and type in this case, the brute force scale that we just wanted to inherit. In other words, we can just type a number. This layer started out scaled to 100%. So let's just type in 100 and hit enter. And now our layer's x value will remain at 100%, and only the y value will be controlled by this comp's layer handle 1b's rotation property. So let's go back once again and adjust our rotation. And as we crank it, you'll see, well, now it works. We turn the crank up and the meter goes up. We turn the crank back down to the left and the meter goes down. In fact, we drag it too far and the meter starts going in the opposite direction, but that's okay. We're not too worried about that yet. So basically, we've constrained in one dimension, which is great. Obviously, we can do exactly the same thing to our second meter here. If I enable an expression for that property and pick whip to rotation once again, this time I'll just select everything that comes after this first phrase and type in 100. Click OK. And now, if I click and rotate, you'll see both meters are happily being controlled by the rotation of our little dial over here on the left. Now, obviously, what I did down here by just typing in 100 is a cheat. I knew that we started at 100%, but if we weren't in a situation where we knew exactly what our scale was, or we just wanted to modify one dimension of an otherwise even animated property where the scale of our layer was actually changing over time, 100 wouldn't work for us here, and we'd actually have to type in a little bit more complicated code. So for those of you who aren't interested in code, just ignore this little bit. For those of you who are, all you really need to do is look at the syntax for the first half of our expression here to figure out what the syntax should be for the second half. If we just kind of imitate the first half of the script here, we can kind of figure out something that'll work for this particular script. We could type in this comp dot layer, and the name of the current layer is meter to green, close parentheses, and we want to use its scale property. And since scale is a two-dimensional property, we need to tell it whether or not we want to use its first dimension or its second dimension. Those dimensions are indicated by putting either the value 0 or 1 in brackets. Programmers always like to start counting at 0 instead of 1. So dimension x is dimension 0, dimension y is dimension 1. So we'll open brackets and type 1 because we want the second dimension and hit enter. Now that'll work, okay? But it's also way too much work for what we want to do right here. We just typed in the hard way because by default, an expression is going to assume all of this bit is true. Let me expand our window a little bit more so we can see everything here. This comp layer meter to green applied to this layer is something we don't really need to do within the context of expressions. Expressions are going to assume that this is true unless you tell it otherwise. So really all we need to type in is scale bracket 1. And that basically tells us, now let's read this whole expression, that we want to get our rotation information from the layer within this comp called handle 1b, but we want to use our own scale y dimension. Now when I hit enter, you'll see that'll work just fine. So when we go back and now modify our rotation, you'll see once again we've got pretty much what we just had before, but instead of typing in a brute force value of 100%, we've told the layer to inherit its own scale, whatever that scale might have been. So let's leave that behind for those of you who are terrified of code and are wondering if that's where we're going to live now for a while. We're not. Let's go to the next composition here, effects, and show that expressions don't necessarily just have to tie to geometric properties, but can also tie to effect properties. For example, in this project, we have a couple handles, just like we did before. We have a bunch of elements in this project that are also hidden right now because we don't want to bother with them. But we also have a wave, which is nothing more than a line in our project that has the wave warp filter applied to it. And if we tap the space bar, you'll be able to see that we have an animated wave moving through our little interface here. We can actually control this wave with our levers if we like. We want to do that. We can do that just fairly simple. Let's take the top one, for example, here, which is handle 2B, and we'll have that control the amplitude of our wave. And then we'll take the other handle and have it control the speed of our wave. So let's come down and set an expression for wave height. And we're going to pick whip that to our handle 2B so that the rotation of the handle controls the wave height. And let's set an expression for wave speed. I'll need to close down this other expression so we can see what's going on here. And select our expression again and pick whip that value down to the rotation of handle 1B. Okay, let me hit enter there and see how well that worked. I'm going to select our rotation tool. Let me actually option click on this and get back to our normal rotate tool. Let me click and drag and you'll see, sure enough, as we spin up this handle, we're getting a higher wave, which is good. If I tap the space bar, nothing's going to happen because we have no speed. But we do have a little bit of a problem here. And that is if I crank this up, we very quickly get to a value just with a little bit of a twist that moves so quickly that there's no sense of motion here at all. It's just absolutely frantic movement. And the problem is a fairly low speed value actually results in pretty decent speed here. So what we need to do is take this value of degrees and actually reduce the results that it produces. And we can do that fairly easily if we just take a quick look at our expression here for wave speed. Let's just divide this value by something fairly large. Because we're starting with rotation as a value, that'll easily produce values up in the hundreds fairly quickly. Obviously, one trip around a circle is 360 degrees. So we would rather be dealing in values that are maybe around, 1 to 4 or so. So let's divide the results of this equation by 100. And instead of 0 to 360, that'll produce results from 0 to 3.6. So I'm dividing the results of our expression by 100 by simply adding /100 at the end of our expression. And when I hit enter and now press the space bar, you'll see the small rotation that we've got in our handle in the window up here is now resulting in a very slow speed. And if I crank that handle up, we get a quicker speed. And if I crank that handle all the way around, we get a much faster speed. So we've essentially modified the output of our expression by using a little bit of simple math. We divided everything by 100, and that allowed us to create an element on screen that modulates things in a much finer resolution than we had before. So this kind of approach to expressions can be very, very useful. And if you have any mathematical aptitude at all for even the simplest of math, you can actually create some pretty cool results. So let's take a look at that. This next little lesson is all going to be done with very, very simple math. Open up the A Little Math composition. And what we'll see here in this composition with a quick tap of the space bar is we've got ourselves a radar screen. And that radar screen rotates around once and then stops. Well, this is a fairly common request in After Effects. How do I create looping keyframes? And the usual answer up until After Effects 5.5 is copy and paste keyframes about 1,000,000 times. Well, I don't want to do that. I can actually use an expression to control the looping of some keyframes. Now, this is not going to be an intuitive thing. This is not simple math. This is a real bona fide expression language trick that you're going to need to learn how to do. You don't necessarily need to learn how to memorize this expression, but you need to get used to going to the help file in After Effects, located up here, After Effects help, and checking out the expression language examples that are in the help, because there are plenty of samples in that help file that you can copy and paste directly in and have them do pretty remarkable things. We have obviously here created a nice rotation of this layer. Now we've done this with the orientation property, not the rotation property. And I've done that because I don't ever want the value that's produced by this rotation to exceed 360 degrees. If we used regular old rotation, then after we got around to the first rotation, we would be to 361, 362, then 400, then 500, and then 1,000 degrees. And by the time we got to the end, we'd have an enormously high number. By using orientation and setting these keyframes about every 120 degrees or so, I'm able to force orientation to give us a nice rotation, and then I'm able to loop this value, after which we can do all sorts of fun things with it. So how do we loop it? Once we've got the keyframe set up that we want to loop, let's enable an expression. We'll do that by option clicking, just as we did before. And if you check out the expression language examples in the help file, you'll find some looping examples. There's a script called loop out. So we're going to type in loop_out. The type of loop we want is a cycle. We just want to cycle our keyframes. And the number of keyframes that we want to loop is all of them. So a value of 0 basically gives us the same thing as saying all keyframes, no matter how many keyframes they are. If I've got 0 typed there, we're going to loop all the keyframes. And if I hit enter, oops, I'm going to get an error message. Now this is going to happen a lot when you work with expressions. Basically what it's telling us is that our syntax is a little wrong. The expression result must be of dimension 3, not 1. Error occurred at line 1. There's only line 1, so that's not very helpful. But a quick glance at my expression tells me I have my second parentheses in the wrong place. If I compare this to the original source sample that was provided for us, this second parentheses should have been at the end here. Once again, I'm not attempting to explain the code. We're just copying a script that somebody else has designed for us. And now when I hit enter, this is going to work just fine. So now, if I generate a quick RAM preview, you'll see that After Effects is now happily looping these keyframes as many times as it needs to fill out the comp. There are some other looping types that you can do. You can loop into a group of keyframes, or you can oscillate keyframes if you like, all of which are useful. But now you see, with only 4 keyframes, we've created an animation that'll loop indefinitely. And the great thing about this now is I could modify the duration of our keyframes down here, meaning the speed of them. And by only changing 4 keyframes, I've now changed the speed of our loop indefinitely throughout the length of the composition at any rate. So we now have a faster little radar effect here, which is great. So looping, very, very useful. That's how to do it with expressions. But I actually promised that we were going to do a little bit of math here, and right now all we've done is just typed in a piece of obtuse JavaScript that produces a loop. Useful though it may be, it doesn't have much to do with math, right? So let's see how we can use the rotational values that we've just created and modified with the loop command to actually control the animation of another layer. And that layer is the little Brian head layer that we see down here. If we turn that on, there's a tiny little Brian head that now appears as a radar blip up here in our radar screen. What I'm going to do, if I zoom in a little bit, is use an expression to vary the opacity of this layer based on the rotation of our radar blip. So whenever our radar blip returns to 0 degrees, the opacity of my layer comes back to 100%, and it quickly diminishes as we rotate around the screen. Okay, so how do we do that? Let me go down, and I'm going to set an expression for opacity. We're going to pick whip the opacity to the orientation of our sweep layer. But don't let go yet, because orientation is a 3-dimensional property. It's got X, Y, and Z information, and all I'm interested in is the Z information. That's the Z orientation, which you can see is actually animated currently to a value of 120 degrees. That's what I want to sample. So if I drag the pick whip over to just one of these dimensions, I can sample only that dimension, which is very handy. So I'm going to let go. Now, in brute force terms, the opacity of this layer is driven by the orientation of the sweep layer. This, by default, is not exactly going to solve our problem, but we'll see what we get when I hit enter. And take a quick look in the comp window at exactly what this gives us. As I move forward through the scene, my little face fades from 0 up to 100% at the point that my rotation gets around to about 100 degrees. So we're now at 108 degrees. My face is at a perfect 100% opacity, and it's going to clip there. You can't have more opacity than 100%. So for the rest of the trip around the screen here, I'm going to stay at 100%. And then when we get back up to the top again and the value is reset to 0, I'll turn invisible and go back up to 100% again when we get down to about 108 degrees. First of all, we need to scale these values because I want the fade to occur throughout the entire rotation that we see here, not just from the first 100 degrees of it, okay? So we can do that very, very quickly as we saw just a second ago with some simple math. We want values from 0 to 360 to equal a range from 0 to 100. So to bring 360 down to 100, all we need to do is divide by 3.6. So now the 360 degrees that are produced by our rotation value are going to be divided by 3.6, and that will give us resulting values that will equal 0 to 100. And a quick look in our comp window again will confirm that sure enough, it now takes a full rotation around the circle before we achieve 100% luminance, and then boop, we pop back to transparent again, and then we appear. Obviously, we have one other major problem here, and that is our transparency is inverted. We want to be 100% luminant at the start, and we want to fade out. So basically, right now, we've got a formula that is producing values from 0 to 100%, but we actually want to invert those values. We want to go from 100 down to 0%. Well, there's a quick little mathematical trick for doing this, and whether you understand it or not, it's worth memorizing. If you want to take values from 0 to 100 and invert them so that 0 actually equals 100 and 100 actually equals 0, the quickest way I've found to do this is isolate the numbers that you're starting with, and the best way to do that is with parentheses. So now everything inside these parentheses is being calculated, and now that's being passed on to what I want to do now. I want to multiply these values by -1. So anytime you multiply by -1, you're inverting values. So now 1 equals -1, 10 equals -10, 100 equals -100. That's still not going to solve our problem here, though, because we don't want to generate an animation that goes from 0 to -100. What we want to do is generate an animation that goes from 100 to 0. So now that we've successfully generated values that go from 0 to -100, all we need to do is add 100 back to this mix, and that's going to solve our problem. If we take a look upright, we've now inverted the values and then offset them by a value of 100. And the result is we get a little ping face showing up on radar, bing, and it fades out as the radar sweeps around, bing, and then pops into place again. So a little creative fudging with math, some fairly simple offset values, some fairly simple addition, maybe a little division, can result in some automatic animation that can be pretty impressive. Now you may be thinking to yourself, what's so impressive about this? I could do the same thing with just a couple of keyframes. Well, what's impressive about this is everything is tied back to this cluster of 4 keyframes down here. The looping of the animation, the transparency of the layer, it's all tied to these keyframes. And now if I modify these keyframes, maybe I want to bunch them together a little bit more to speed things up. Since everything is driven by expressions now, all I do is adjust those keyframes and everything else keeps up. No matter how quick or how slow we decide we want things to go, expressions are driving things now, so everything keeps up just fine. The last little area I want to talk about in this introduction to expressions has to do with text. In this composition, we've got ourselves a simple little background. It's just got an animated 4-color gradient with colorama applied to it and then the grid effect. We're going to add some text to this. We hit Command-Y, Control-Y on Windows, and create a new layer called Text. And let's apply Effect, Text, Basic Text. And in the text, we're going to choose a font that actually has letters in it, not webdings. Something really simple like Arial, narrow, boring but simple. And let's type in Blurring and Bleeding. Center the fonts, click OK. It's a fairly awful red color now, as it always is in After Effects when you first start out. Let's crank these values up. So we got a nice little starting position here. Let's now apply a blur. We're going to apply Blur and Sharpen, Fast Blur. And for now, let's tell it to just blur horizontally. Now what I'm going to do is I'm going to tie the blurriness to the tracking or the kerning of our text, thus giving us blurring. We can also adjust the line spacing and the blurriness together, thus giving us bleeding instead of leading. So let's quickly solo the properties we want to work with here. We're going to work with blurriness, tracking, and line spacing. Now that I've enabled keyframes for all of those, I'll hit the letter U to bring those properties up down in the timeline. And now what I want to do is I want to enable an expression for blurriness. So I'm just going to option click on our blurriness, and I'm going to pick whip up to our tracking first of all and let go. Hit enter, and now watch what happens. As I adjust the tracking or the kerning of our letters up here, you'll see we immediately get blurring applied as well. So we've tied the blurring of our letters to the tracking of our letters. So you can easily see that with just a couple of quick expressions, you can, with just one or two keyframes, adjust multiple things at the same time. Now, if instead of adjusting the blurriness based on tracking, we decided to adjust it based on line spacing, we'd merely select the expression again, pick whip that up to line spacing, hit enter, and see that we immediately get some blurring going on. That's because the line spacing value defaults to 100%. Now I can crank up the line spacing and we'll get even more blur, but obviously our 100% starting value is giving us more blur than we want here. This is a great example of when you would need to offset the values, which we can do by just typing -100 at the end of our expression. And now by adjusting the line spacing again, either down on the timeline or even right here in the effects palette, the line spacing will also simultaneously control the blurring of our layer. So lots of cool stuff you can do here. Expressions are incredibly powerful and allow you to tie layers to each other. And as we saw a tiny little hint of with the looping command, they allow you to do a lot more powerful stuff besides. As we'll see in the very next lesson, wiggle.